right to it. Okay, everybody, so find your number one. We're gonna breeze through as many as, oh, come on, do not be frozen on me again. Hold on. So annoying.
Just trying to say, in the fractures of 1863. The imagination, life is your creation. The song's actually good though.
All right, now, is it still sharing? Share this, yes. All right, let's see if it's live now. For goodness sakes. Oh, thank goodness. Okay, everybody.
Oh, guys.
Speed round here. You ready? Yes, we don't have a lot of time tonight, but
Oh, and
we're gonna try and get to them all.
I didn't even know there was one right there.
Okay, so here's number one. All you're doing here is simplifying. So step one is factor whatever you can. From the top, I can take out a 4. From the bottom, there's nothing to do. So I factored everybody. Now I can reduce whatever can be reduced, 4 over 16. That's it. That's my answer. B plus 4 over 4b squared. You can't go any further than that. You are finished. Oh, yeah, I forgot. Oh, yeah. Sorry. Thank you. There's your answer. Just kidding around.
That's you getting it.
See what happens when you go fast? All right, number 2. Number 2. Oh, wow, another one. But in the numerator, I can take out a 6. I can factor that even further. That splits into m plus 2, m plus 1. That numerator is now fully factored. Downstairs, I can take out a 3, and then I'm left with m squared minus 4. But wait, doesn't that split again? Because that's the difference of 2 perfect squares. So that becomes m minus 2, m plus 2. Now everything is fully factored. Now I get to start reducing. Oh, look, m plus 2, m plus 2. I can reduce the 6 and the 3. And I think that's it. So what's left? Up top, I have 2 times m plus 1. On the bottom, I have m minus 2. Done. Number 3. Find your number 3 somewhere. Here it is. Oh, lovely. This one's just multiplying. So factor everybody. No one needs any factoring. So then I get to jump right into canceling. I'm going to reduce or cancel anything in any numerator with anything in any denominator. You don't have to be in the same fraction, but they can be. So right away, I see x and x are going to cancel. I can reduce the 6 and the 20. So reduce by 2, that'd be 3 over 10. I can reduce the 3 and the 15, 1 and a 5. And that's it. So multiply, share across, I get 13 over 50, and I'm done. Number 4 is a division problem. Division, step 1, rewrite as multiplication of the reciprocal. Times, and now I flip this fraction over. So I have n squared minus 9n plus 18 on top, n squared plus 2n minus 15 on the bottom. Now it's a multiplication problem, right? So now all I have to do is factor everybody and cancel who will cancel. So what does that factor into? Minus 6 minus 3. This one can be plus 5 minus 3. Everybody is factored. Now let's cancel. N plus 5's cancel. N minus 3's cancel. Can you do anything with that n minus 6 and that n plus 6? No, they're not the same. And I can't make them the same. So there's my answer. Done with number 4. So far, so good? Yeah, okay, 5. 5 is a multiplication problem, so I just factor and cancel. So up top, let's see, 7x squared can come out. That would leave me with x minus 2. Oh, tell me something comes out of this.
Yeah, it does. Just
I don't think I can.
X minus 3 and then 3x plus
7x minus 3, and what was the other one?
5.
3x plus 5. All right, so that one you just have to factor. I would take the time, but I don't have the time right now. So factor however you do it. Over here, I can take out what, 6? So that's 7x minus 3. Over here, I can take out 7x squared. So I get 3x plus 5. All right, that looks good. So everybody is now factored. So let's now go ahead and cancel. Ooh, 7x squared, 7x squared. That's kind of nice. 7x minus 3s, 3x plus 5s. That's it. I'm done. X minus 2 over 6. Easy peasy. Now, number 6 starts with the subtraction. This is where things get more annoying because you need common denominators, right? So I start off by factoring my denominator. I'm going to take out a 3x, and that would leave me with x minus 7. This one, so see how they both already have a 3? Great, so I don't have to worry about that. But this first one doesn't have the x or the x minus 7. So I have to multiply that first fraction by x times x minus 7. I'm just going to cross out the problem number here so we don't get messed up. So I have to do x times x minus 7 on top and on bottom. All right, so now both parties have the same denominator, right? Right. So now I'm just going to subtract the numerators. Up top here, I got to multiply all that together. So that's x squared minus 7x times 8. So that's going to be 8x squared minus 56x. And then notice, look, you are subtracting this whole fraction. So that's now minus x plus 2. Be careful. So my numerator now becomes 8x squared minus 57x plus 2. And it's all over the common denominator, 3x times x minus 7. Does that factor any further? No, I think that's it. So we are done. Adding and subtracting, get those common denominators, and then you just add or subtract the numerators, leave the denominator the same. All right, number 7. Okay, now we're up to equations. Remember, with equations, we want everybody to have the same denominator, and then I get to ignore them. That's so nice about this. So first I'm going to factor on n. I have n minus 4. Same thing over here, n minus 4. So now it's pretty easy for me to see, oh, okay. The only thing that I need is that middle one needs n minus 4, right? Right. So let's multiply the middle one by n minus 4 on top and on bottom. Okay, everybody has the same denominator, right? Great. Now I literally just do the numerator. So watch, 1, but you have to minus all of this. So it's minus n plus 4 equals 3. So important. You got to be so careful with subtraction. And now I just solved this equation, easy peasy. So that's negative n plus 5 equals 3. That'll be negative n equals negative 2. I get n is 2. By the way, Jack, if you look at the answer key, I heard you say that. Those are squiggly bars, not absolute values. So it's just 2.
I looked at it.
Okay, so there's that. And don't forget to double check real quick and just make sure that an answer of 2 doesn't make anything in your original have a 0 in the denominator. It does not, so it's fine. Oh, wait, does it? No, it's fine. Okay. Great. Okay, number 8, same idea. I have another equation. Where are you, number 8? There you are. So I gotta get common denominator. Step 1, factor. All right, cool. So I noticed this one needs m plus 6. This one's gonna need m plus 2. Great, everybody has the same denominators now. I get to ignore them. Let's do the numerators. 4 minus all of this, so it's minus m minus 6 equals, now I gotta FOIL this side together. M squared plus 2 minus 4 is a minus 2m minus 8. All right, this is just a quadratic. I'm just gonna set the whole thing equal to 0 and solve from there. So let's add m. And that's gonna be a -2, so I'm actually gonna add 2 to both sides. So now I'm here, let's factor. -3 and a +2, right? Yep, so my answers are actually a +3 and a -2. However, can you leave both of those answers? This time you cannot. Why? Because if I look at my original, look at what my answers are, 3 and -2. Wouldn't a -2 give me a 0 in the denominator right there? That's a problem. So that means -2, I'm sorry. I can't accept you as an answer. You're going to make the universe explode, but 3 is fine. So the only answer to this is 3. All right. 9, ooh, complex fractions. If you have one fraction over one fraction, you're actually ready to just do keep, change, flip. So we keep the numerator as it is, 3 over x squared. We change the division bar to multiplication, and we're going to flip the bottom fraction, x plus 2 over x squared. Now it is a multiplication problem. Factor everybody, cancel whatever you can. Nobody factors and nobody cancels. So if I just multiply straight across, I get 3 times x plus 2 over x to the 4th. If you want to multiply out that numerator, you can. You don't have to. It's no big deal. What number is this? 9. Yeah, okay. Now, 10 is a different story. 10, I don't have a single fraction over a single fraction. So this is the one that I keep saying, all right, let's just focus on the numerators for a second. Okay, I need to combine that into one single fraction. So I need a common denominator, 45, right? So multiply this one by 5 over 5, this one by 9 over 9. So this new fraction is going to be 100. That's 9a minus 27. So when I add those numerators together, look what I get. 9a plus 73. Oh, over 45. Shoot. Let's stick it right there. There's what I get, right? Everybody's okay there? Now I'm going to do the denominator. Same thing. So pretend the numerators don't even exist. Now I'm coming over here. It just so happens that the common denominator here is also going to be 45. That doesn't normally happen, but it did this time. What's 5 times 6? 16 is 80. So I get 80 over 45 plus 27 over 45, which is 107 over 45. Now I have a single fraction over a single fraction, so I'm ready to do keep, change, flip. Keep 9a plus 73 over 45. Change to multiplication, flip this one over. 45 over 107. And now again, it's a multiplication problem. Factor everybody, cancel what you can. Cancel, cancel. Does anybody else factor? I don't think so. So there's my answer. 9a plus 73 over 107. Done. I could actually finish all of them. I'm so excited. Let me not jinx myself though. Okay, the last two are these types of problems. We just went over these. Jenny can pick 40 bushels of apples in 12 hours. Pranav can pick the same amount in 8 hours. How long would it take them if they work together? Don't get thrown off because they say 40 bushels of apples. That 40 is just there to throw you off. Picking 40 bushels is the one job, right? Jenny can do 1/12 of it. I don't know how long it's going to take her. Pranav can do 1/8 of it every hour. I don't know how long it's going to take him. but they complete one whole job together. Okay, so who cares that it says 40 bushels? It doesn't matter. That's what I'm looking for. So my equation, x over 12 plus x over 8 equals 1. Let's clear the fractions. Does 8 go, 8 doesn't go into 60, does it? No. I think I gotta do 120. So that's 10x, what is that, 15? I don't know. What's 120 divided by 8? You guys are supposed to be smarter than me. Could. Didn't think of that number. Anyway, but it's okay. I'm already too far past it. But yeah, you totally could have. Wow. So you guys are smarter than me. So 120 divided by 25. We should still get the same answer. It doesn't matter. 4.8. A reasonable answer. I knew the answer should have been less than 8 at least. 4.8 sounds good. Okay. All right. Last one. Here we go. Same idea. Oh, again, with these 40 bushels of apples. I don't know what the, but who cares? That doesn't matter. Stefan's going to pick 1/12. He's going to complete 1/12 of the job every hour. It tells me that he worked for 5.45 hours. So this time I know how many hours they worked for. Now I come over to Rob. I don't know how long it would take Rob to do it by himself. So I don't know what portion of the job he's going to do every hour. But I know he works for 5.45 hours. Together, they still complete one whole job. So if you write this fraction nice and neat, 5.45 over 12 plus 5.45 over x equals 1. Now I could have asked you this question in the equation section. You can forget that it's a multiple word problem. I just need common denominators, 12x, right? So I can multiply this one by x over x, this one by 12 over 12, and this one by 12x. So everybody has the same denominator, so my numerators read 5.45x plus, it's 5.45 times 12. It is 65.4. Subtract the 5.45x. 12 minus 5.45 is 6.55. Divide both sides, and we're going to get x is equal to 9.98. I'm going to round that to 10. What's the hours? You are not. That's it.
Oh my God.
What would it take
I'm so
for like the whole, like the one job to be like in the equation? Would there ever be like?
It's not going to be for us, but I guess, I mean, you could set up a problem where they, you know, maybe they put up, go back to someone else, like putting up a deck. Maybe they put up 2 decks. But then it's so silly. If I say, hey, it takes Rob 20 hours to put up 2 decks, couldn't I just say, okay, well, it takes 10 hours to do 1? You know what I mean? So, yeah. All right. Woo! Can't wait for you to take this test tomorrow and be officially done. Oh, did you send it to me? I don't think I got yours.